Hello, teacher. Good
Hello,
evening.
good evening, Majo. How are you? Is everything okay?
Yes, teacher, and you?
Great, everything is fine. Thanks for asking. So we're going to begin the practice as we always do. I'm going to share the sound of my computer to start listening to this lecture. All right. So again, if you want to take notes, please do it because I'm going to play something for you and you have to answer some questions afterwards. All right.
Okay, teacher,
So,
give me 1 second, please. Yeah.
of course. Go ahead. Go ahead, please.
Okay, teacher, I'm ready.
Okay, perfect. There you go. Now let's listen, please. I'm going to play only the first part. Try to pay attention to the topic, right? What this lecture is going to be about, and some details that you may catch. So let's listen.
Hello, class. So today we're going to be looking at facial recognition and to the different sorts of technology that go into facial recognition. Now, before we start, can any of you tell me where we can see facial recognition in action? Yes, you at the back?
In the TV show Las Vegas?
Well, you're right. In this popular TV show, the security team pull images of the individuals from their surveillance system and run the image through a database to identify the person.
Okay, that's the first one. The second part is more like, right, the professor is making some students participate and she made a comment, right? But up to that part, were you able to identify what the topic was? What were you able to get, Majo? Let me know, please.
It's a technology or it's some to technology, teacher. Maybe a face recognition.
Okay, good. Yes, exactly. That's the one, all right? Facial recognition. Okay, good. I'm going to play once again so that we can understand everything in detail. All right, so let's play it once again because afterwards he's going to give more explanation, so it's important to understand everything. Let's listen.
Hello, class. So today we're
Okay, right, so he's greeting, and so today we're going
to be looking at facial recognition.
Right, we're going to be looking at facial recognition. So that's the one. Exactly.
And to the different sorts of technology that go into facial recognition.
Okay, and to the different sorts, right, kinds of technology that go and that are related to that technology, all right? So that's going to be the main topic, facial recognition and everything that goes related to that.
Okay.
Now, before we start, can any of you tell me where we can see facial recognition in action?
Right, and before we start, right, he asks one question to the students. Can anyone tell me where we can see facial recognition in action? Right, and that's where the girl gives the example of a show, right? They laugh, but he says, right, that's right. In that show, we can see that. So let's listen to that part.
Yes, you at the back?
In the TV show Las Vegas?
Well, you're right. In this popular TV show, the security team pull images of the individuals from their surveillance system and run the image through a database to identify the person.
Okay, here they are only giving an example that in a TV show called Las Vegas, right? They use this technology, right? They analyze the images and they use facial recognition with some people. At least that's what we get. Okay, so up to this part, I'm going to keep going. And here I'm going to ask more specific questions. So let's pay attention from this part.
In that way, all the card counters and blacklisted gamblers can be escorted from the poker tables. It looks easy on TV, but in the real world, facial recognition is a tricky business. So let's start with the more traditional methods of facial recognition. Every face has peaks and valleys, and these can be translated into what is termed as nodal points. Each face has about 80 of these, and they include distance between the eyes, the length of the jaw, the width of the nose, things like that. These measurements can be used to create a numerical code, and this is called a face print. This system is good because it can compare two-dimensional images such as photographs. The problem is that images have to be controlled. The person has to be staring straight at the camera. There must be no variance in facial expression or lighting because any variance in these parameters reduces the effectiveness of the system.
Okay, that's the first part. I'm going to play once again and try to take notes and try to get every detail, please, Majo, because you're going to explain this first type of facial recognition, okay? Because we have many kinds, but this is the first one. Try to get the characteristics, all right? I'm going to play once again and try to take notes as much as you can.
Popular TV show identify the person. In that way, all the card counters and easy on TV. So let's start with the more traditional method.
Okay, here, all right? Let's start with the more traditional methods. From this part, this is important.
Methods of facial recognition. Every face has peaks and valleys, and these can be translated into what is termed as nodal points. Each face has about 80 of these, and they include distance between the eyes, the length of the jaw, the width of the nose, things like that. These measurements can be used to create a numerical code, and this is called a face print. This system is good because it can compare two-dimensional images such as photographs. The problem is that images have to be controlled. The person has to be staring straight at the camera. There must be no variance in facial expression or lighting because any variance in these parameters reduces the effectiveness of the system. So they had to come up with another way.
Okay, so before going to the different methods, what can you tell me about this first method that is the traditional method for facial recognition?
Okay, it's a TV program that and they use a method traditional that every face has a different, and they analyze the distance with eyes, mouth, and wide to the nose.
Okay, good. Yes, and at the beginning, right, they talked about the TV show, and good, that's part of the first example. But now, this traditional method, right, that's not related to the TV show. That was a different example. But yes, you're right. In the explanation, when they finish talking about the TV show, right, that's finished, they start talking now about types of facial recognition. And this is the traditional. Now, I'm going to ask you that one. You're saying that there are some differences or some characteristics, right? For example, the eyes, the nose, but how does it work? How does a camera knows that one person is one person using that information? What can you tell me about that?
Because they recognize the distance with the characteristic to face.
Okay. The distance, for example, between what parts of the body or what parts of your face?
Between eyes, a mouth, and the wide to nose.
Okay. And what is one big disadvantage? Because this is the traditional method. And they say that, well, there is a big disadvantage. What are the disadvantages related to this method, the traditional method?
I don't know, because they how do you say medidas? I don't know, teacher. I don't know.
Okay.
Yeah, one more.
Okay. We're going to go to the first part, but you're doing good. Okay, it's a good job, Majo. But we're going to try to get what is something very important for these traditional methods that makes this not that good option. All right, so let's go to the first part and let's analyze first the main ideas.
In that way, all the card counters and blacklisted gamblers.
Okay, that's part of the previous idea.
On TV, but in the real world, facial recognition is a tricky business.
Okay, so here we start, right? It's a tricky business, so it's something difficult to do. It's not as easy as it seems on the TV, right? It's hard to do it.
So let's start with the more traditional methods of facial recognition.
Okay, so here we start with the traditional methods.
Every face has peaks and valleys, and these...
Okay, it says, right, every face has peaks. Peaks are like the higher points, right? Like the nose, for example, and valleys. Right? What is a valley? For example, your eyes, because they are like different, right? It's the opposite to a peak. A peak could be your nose, and a valley could be your eyes, right? A peak could be, I don't know, your ears, and a valley could be, I don't know, something related to your mouth. Okay, so for example, in Bolivia, if you want, Cochabamba, right? That's a valley. That's a valley, Cochabamba. But you can say that La Paz, Oruro, and other places are on the peak, right? So highest and lower points. So each face, all right, has valleys and peaks. And those are going to be main elements, as you were mentioning very well, right? To help us identify some people.
These can be translated into what is termed as nodal points.
Okay, and this is very important. They are translated into nodal points. Nodal points are just references, right? You have one nodal point in your nose, on your nose, on your eyes, on your chin, on your cheeks, and other parts of your face. So those are nodal points, okay? Important points in your face that are going to help us identify, well, who you are.
Each face has about 80 of these, and they
Okay, that's important. We have a number. So how many nodal points do we have where each face has a map? Were you able to get that one?
Maybe five, no, 5 or 6: eyes, nose, mouth, and ear.
Okay, let's try to listen one more time. We're going to verify.
each face has about 80 of these.
Okay, actually it's 80. Okay, it's a lot. 80
Yes.
nodal points, right? So okay, so it's a lot. So it's not only the nose, it's one part, a nodal point, but you have a lot of nodal points in your nose, right? Then you have a lot of nodal points in your eyes, in your, I don't know, cheeks, chin, mouth, ears, right? Even your hair. So a lot of things to identify, 80.
And they include distance between the eyes, the length of the jaw, the width of the nose, things like that.
Okay, and those are the things that you were mentioning, right? It includes a lot of things.
These measurements can be used to create a numerical code, and this is called a face print.
Okay, so this is important as well. So what is a face print? I'm going to play once again. You're going to try to tell me what is a face print.
Can be used to create a numerical code, and this is called a face print.
Okay, so what is a face print, Majo, according to what you understand?
Is that we have a different characteristics in our face to help
Also
to
that.
identify our facial recognition.
Okay, and to be more specific, we're talking about the nodal point, right? And if we listen to this part,
these measurements can be used to create a
also the expressions, but actually this is one of the disadvantages that we're going to learn later on. If you change your expression, this method doesn't work. Okay, that's one of the disadvantages. But let's listen. What is a face print?
measurements can be used to create a numerical code.
Okay, so those 80 nodal points that you have are used to create a numerical code, all right? A numerical code. And actually that numerical code, because of the way your 80 nodal points are organized in your face, that is what we call this.
And this is called a face print.
Okay, the face print. So again, every right face is different, of course, because of those 80 nodal points are in different places, and that's a numerical code for you, and that is your face print. And now let's pay attention to this last part. You're going to try to tell me, as I was telling you, the disadvantages. What is something that we cannot do with this kind of facial recognition?
This system is good because it can compare two-dimensional images such as photographs. The problem is that images have to be controlled. The person has to be staring straight at the camera. There must be no variance in facial expression or lighting because any variance in these parameters reduces the effectiveness of the system.
Okay, so what can you tell me about the problems, the disadvantages related to this method, Marco?
Teacher, they have an advantage because they have to be a control, and the person has to be straight at the camera.
Okay, good, good. So that's a disadvantage, right? This kind of technology cannot be used when the person is moving, when the person is making a different expression, when the person is not looking straight at the camera, right? So there are many, many problems with this one. We're going to listen to that again.
The problem is that images have to be controlled.
Okay, images have to be
Have
controlled.
to be
That's the
controlled.
first disadvantage, right? That's the first problem. Then,
The person has to be staring straight at the camera.
okay, the person has to be staring, looking at, right? Staring straight at the camera.
There must be no variance in facial expression or lighting.
There must be no variance in facial expression or lighting, right? So if you change the lighting, if you change your expression, this facial recognition is not going to work. Okay, so it's not that good.
Because any variance in these parameters reduces the effectiveness of the system.
Okay, so any variance, any changes are going to reduce the effectiveness, right, of this kind of technology. Okay, and that's it. Because of the time, that's going to be it. I don't know if you have any questions or comments related to this, Majo. Let me know, please.
No, teacher, anything.
Okay, very good. Again, I hope you have some interesting words over here, and it's important to get that vocabulary. That's it. I'll see you tomorrow for the next class. Remember to work on your presentation. Friday, we're going to have again the oral presentation, and we're going to need to upload all the recordings. Tomorrow, we're going to work with at least 3 or 4 more recordings, okay, besides the vocabulary one. That's it then, Majo. Thanks for being here. Have a good night and see you tomorrow.
Okay, teacher, see you tomorrow. Bye. Bye,
Bye-bye.
Tefa.
Hello, teacher.
Hello, Estefania. How are you? Is everything okay?
Yes, teacher.
Okay, that's good. So let's begin today's practice with you. You know how this works. We're going to listen to a lecture. If you want to take notes, do it. I'm going to be asking you some questions, all right? Again, I'm going to divide this in 2 main parts, the introduction, so that you can tell me what's the topic and the main idea here. And then we're going to listen to the content, and I'm going to ask you specific questions, all right? Let's begin. Are you ready? Do you have something to take notes on, Stefania?
Yes.
Okay, let's begin then.
Okay.
Hello, class. So today we're going to be looking at facial recognition and to the different sorts of technology that go into facial recognition. Now, before we start, can any of you tell me where we can see facial recognition in action? Yes, you at the back?
In the TV show Las Vegas?
Well, you're right. In this popular TV show, the security team pull images of the individuals from their surveillance system and run the image through a database to identify the person.
Okay, up to that part, before going to more details, the last part was just an example, let's say, right? But what can you tell me about this first part, Estefania? What is the main idea or topic here in this lecture?
He is talking about facial recognition, and he asked his students where they can I don't know, find a facial recognition, something like that.
Good. Facial, right? Facial recognition. Okay,
Facial, yes.
good. So in that question, right, he asks, where can we find facial recognition in action? Do you remember what's the answer of the girl and what the professor says about it?
Yes, she said Las Vegas, TV Las Vegas, or TV show Las Vegas. And the teacher, I don't know, answered that yes, and it's a really a popular show. And I don't remember more.
Okay, it's okay. Very good, right? In this case, you can call this person like a professor, right? Because when it's at university, they're going to be professors. So this professor, yes, is answering back and replying saying, yes, you're right. In that show, right, Las Vegas, you were right. They use that technology in the security cameras, right? Because of course, and there are many obvious reasons in Las Vegas to use that kind of technology. So we're good so far. I think it's clear. Now let's pay attention to this next part because here we have very important information, Stefania. Pay attention because this professor is going to explain a traditional method of facial recognition, okay? Try to get important elements because you're going to try to explain, Stefania, how this technology works in detail, what parts of our body or of our face, right, better said, of our face are analyzed and what are some problems or disadvantages that it has. Okay, that's one thing that you should pay attention to. So let's keep playing and try to take notes related to those elements. Here we go.
So let's start with the more traditional methods of facial recognition. Every face has peaks and valleys, and these can be translated into what is termed as nodal points. Each face has about 80 of these, and they include distance between the eyes, the length of the jaw, the width of the nose, things like that. These measurements can be used to create a numerical code, and this is called a face print. This system is good because it can compare two-dimensional images such as photographs. The problem is that images have to be controlled. The person has to be staring straight at the camera. There must be no variance in facial expression or lighting because any variance in these parameters reduces the effectiveness of the system. So they had to come up with another way.
Okay, before going to the other one, I'm going to play this once again. Okay, so try to complete the ideas that you are writing down and let's do it. All right, I'm repeating the same part.
It's easy on TV, but in the real world, so let's start with the more traditional methods of facial recognition. Every face has peaks and valleys, and these can be translated into what is termed as nodal points. Each face has about 80 of these, and they include distance between the eyes, the length of the jaw, the width of the nose, things like that. These measurements can be used to create a numerical code, and this is called a face print. This system is good because it can compare two-dimensional images such as photographs. The problem is that images have to be controlled. The person has to be staring straight at the camera. There must be no variance in facial expression or lighting because any variance in these parameters reduces the effectiveness of the system. So they had to come up with another way.
All right, so that's it. So again, in general, try to tell me what you were able to understand, Stefania. And if you can organize the information in the sense that I was telling you, right? Explaining how this works, what parts of the face are involved there, how that technology is working with those parts, and some problems that it may have, all right? Try to do it. If not, give me a general summary of everything, please.
Okay, teacher, I understand that the most common system, I think, is with the instance of eyes and something with your nose and I don't remember what more, but all of these create a number code that is to recognize and also remember that I don't know, I think the problem with this a program is that the images or photographs that they can needs to be controlled, and I understand something like that.
Okay, good. We're good so far. We need more elements, all right? I'm going to try to go with you a little bit more, but you're right. That's one of the problems. The images needs to be controlled. And yes, those are some important elements, right? The distance between the eyes, the width of the nose, and other elements are important because they create what you mentioned, right? A numerical code. So good. I'm going to play once again. I'm going to be stopping, all right? And I'm going to be asking you some questions. So let's begin.
Start with the more traditional methods of facial recognition. Every face has peaks and valleys, and
Okay, so here we start with that one. Every face has, let's listen.
every face has peaks and valleys, and these
Okay, every face has peaks and valleys. How do you understand that one, Stefania? What can you tell me about that?
I don't know, teacher.
Okay, for example, in Bolivia, right? The cities that are in the middle of the country, do you know what are the cities that are in the middle of Bolivia?
No, the cities. I don't know.
Okay, for example, Cochabamba, right? Cochabamba is in the middle of,
Okay. Yeah.
right? Because we don't call departments in English, right? That's a different thing. We call them cities. So Cochabamba, right, is one city that is in the middle of Bolivia. What is the characteristic of Cochabamba? That it is a valley, right? So what is a valley? A valley is like one thing in between high things. For example, in between the mountains. For example, in your face, your eyes are valleys and your nose is a peak, right? So on your face, you have valleys and peaks. Peaks are the high things, okay, like your nose, and valleys are the ones like your eyes that are the opposite. Okay, that's more or less the idea. I don't know if you get those two words now, Stefania. Let me know.
Yes, teacher. I think that yes.
Okay, so we have peaks and valleys. It means that our face has a lot of characteristics, right? Our eyes, our cheeks, our mouth, our nose, and so on. So those have different forms, different shapes, right? And you can call those also, I was telling, okay, valleys and peaks. Let's keep going.
Okay.
can be translated into what is termed as nodal points.
Okay, this can be translated as nodal points. So every part of our face is going to be a nodal point, and that's the name only that you're going to give to those specific parts of your face that have specific characteristics.
Each face has about 80 of these, and they
Okay, so how many nodal points do we have in our face, Stephanie? Let me see.
Nodal. What is nodal?
A nodal point is the name that they give to the specific parts of our face that are different in every person. Okay, so a nodal point can be many things. In this case, it's just the name. For example, let's say I don't know, the left part of your eye, that's going to be one nodal point. The one above your eyebrow, that's going to be another nodal point because it's different in you. I don't know, the one part that is in the middle of your lips, that's going to be another nodal point. Okay, so nodal points are many parts of your face that have, okay, different characteristics. So if you listen here, they say the number. You're going to tell me how many nodal points we have in or on our face.
termed as nodal points. Each face has about 80 of these, and they
Okay, so what is the approximate that we have?
80.
80, there you go. So we have a lot, right? In just
Yes.
our face, we have 80 nodal points. Let's keep going. And here you're going to explain then how we get the numerical code.
include distance between the eyes, the length of the jaw, the width of the nose, things like that.
Okay, so here we're talking about measurement, right? Distance and many other characteristics that are part of our face. And he says the following.
These measurements can be used to create a numerical code, and this is called a face print.
Okay, so how do we create this face print, and what is the face print?
I don't know, teacher. What is phrase print? I don't know.
It's related to what you said at the beginning. So let's try to get this together. Look.
That.
So we were talking about measurements, right? Distance between the eyes, the width of the nose, and so on. That is?
These measurements can be used to create a numerical code.
Okay, those measurements can be used to create a numerical code. And pay attention, here is the answer.
And this is called a face print.
So what is the face print? What do you say?
The code? I don't know.
Yes, exactly. A face print is the numerical code. And the numerical code is the measurements that we have in the parts of our face, right? And that's those measurements are related to the nodal points. And the nodal points are related to the valleys and the peaks that we have in our face. So in other words, all the characteristics that our face has, all right, can be evaluated by this technology, and it creates a numerical code, a face print, right, that is going to be unique to each person, all right? So take that into account. To finish this, I'm going to keep going just the last part. Pay attention to the problems. You mentioned one, but we have more. Pay attention to the problems that this technology has using that, let's say, characteristics that we set.
This system is good because it can compare two-dimensional images such as photographs. The problem is that images have to be controlled. The person has to be staring straight at the camera. There must be no variance in facial expression or lighting because any variance in these parameters reduces the effectiveness of the system.
Okay, so what do you say about the problems with this technology?
I don't know, the person needs to be quiet. I don't know it's the correct word, because if they move the image or photograph, it could be bad. I don't know, I think it's the problem.
Okay, go ahead. I just wrote that one because instead of quiet, you can use that expression. That means that you cannot move. Okay, when you stand still, you cannot move.
Stand still, okay.
Okay, good, good. So let's listen once again. I'm going to help you out, and we're going to finish with this.
The width of the nose, things like that. Numerical code, and this is called good because the problem is that images.
Okay, so the first one, right? This is the first problem.
Have to be controlled.
Right, the images have to be controlled, right? We're talking about photographs, but you need to have control over those ones to analyze that in detail. That's the first problem.
The person has to be staring straight at the camera.
The person has to be staring, right? Looking straight at the camera. If you're not looking at the camera, perhaps this is not going to work.
There must be no variance in facial expression or lighting.
Right, there must be no variance, no changes on the facial expression that you have and the lighting. So for example, if the one photograph, right, was you were smiling and it was with daylight, and the other photograph you were like serious and it was at night, then this technology is not going to work, right? So those are big problems, and those are the problems that we have. That's it. I don't know if you have any questions, observations, or comments related to this to finish this up, Stephanie. Let me know, please.
No, teacher.
Okay.
Everything is clear. Thank you.
Okay, there you go. Just a reminder, please, this Friday we have another oral presentation. The characteristics and everything you have to do are the same as the previous week. You can take a look at the criteria if you want, just in case. And tomorrow we're going to finish working with more activities, okay, to have more in-class activities. And don't forget about the vocabulary as well. That's it. Thanks for being in this conversation, and I'll see you tomorrow in class, Stephanie.
Okay, bye, teacher. Bye,
Bye.
Mala.
Bye, Papa.
Hello, good evening, Melanie. How are you?
Hi, doing so good. What about you?
Great. Everything is fine. Thanks. So let's begin with this practice. We have, as always, a different lecture. Please have something to take notes on. I'm going to play this in two main parts. The first one is going to be for you to identify the main topic, the main idea of this lecture, and then I'm going to make you listen to the specifics so that you can, well, explain in more detail, all right, what this is about. Let's begin, all right? Let's begin, and let's start now.
Hello, class. So today we're going to be looking at facial recognition and to the different sorts of technology that go into facial recognition. Now, before we start, can any of you tell me where we can see facial recognition in action? Yes, you at the back?
In the TV show Las Vegas?
Well, you're right. In this popular TV show, the security team pull images of the individuals from their surveillance system and run the image through a database to identify the person. In that way, all the card counters and blacklisted gamblers can be escorted from the poker tables. It looks easy on TV, but in the real world, facial recognition is a tricky business.
All right, up to that part. What can you tell me about this lecture, Melanie? What this is about and some details that you were able to get, please.
Okay, so this lecture is about the face recognition. And so this is a topic for technology. And the professor is asking to the students that if they know this kind of technology in action. And again, mentioned a TV show. And yeah, in fact, in this kind of TV show, there is this type of technology. However, what is difficult to do is to put it in the real world. She also, the professor also mentioned how if this works, like you put this face recognition in a database to identify, the picture, the face, and maybe open some doors and things like that. So that is what I catch of this lesson.
Okay, thank you very much. I think that's it. I think we don't need to go back. You were able to get the most important things, facial recognition, right? And you were right. Actually, he was talking about how this worked in that TV show, right? But afterwards, he's going to say that actually it's not as easy as it looks, right, on the TV show. It's not using something and putting that on the database, right? That's what happened in that TV show. But later on, he says, actually, it's not as easy as it looks, right? It's going to be more complex. And that's something that we're going to listen to today. Not everything, but we're going to listen to at least the first method, that is the traditional method of facial recognition. So again, everything was very good. Now you need to pay attention to the following, Melanie. First, you're going to try to understand how this works, this first method. I mean, what parts of the face are analyzed? In what way are those parts of the face analyzed? What is created using those parts and how it works in general? And then you're going to try to mention some problems that this method may have. Okay, that's important to take into account. So let's listen from this part. Let's pay attention to that. We're going to listen 2 times to this. This is the first one.
So let's start with the more traditional methods of facial recognition. Every face has peaks and valleys, and these can be translated into what is termed as nodal points. Each face has about 80 of these, and they include distance between the eyes, the length of the jaw, the width of the nose, things like that. These measurements can be used to create a numerical code, and this is called a face print. This system is good because it can compare two-dimensional images such as photographs. The problem is that images have to be controlled. The person has to be staring straight at the camera. There must be no variance in facial expression or lighting because any variance in these parameters reduces the effectiveness of the system.
Okay, that's the first one. Now I'm going to play once again for the second time, and then we're going to explain everything in detail. Here we go. This is the second time.
Way, all the card counters and blacklisted gamblers can be escorted to tables. It looks easy on TV, but in the real world, facial recognition is a tricky business. So let's start with the more traditional methods of facial recognition. Every face has peaks and valleys, and these can be translated into what is termed as nodal points. Each face has about 80 of these, and they include distance between the eyes, the length of the jaw, the width of the nose, things like that. These measurements can be used to create a numerical code, and this is called a face print. This system is good because it can compare two-dimensional images such as photographs. The problem is that images have to be controlled. The person has to be staring straight at the camera. There must be no variance in facial expression or lighting because any variance in these parameters reduces the effectiveness of the system.
All right, so that's it. Try to tell me now, please, Melanie, in general, if you want everything that you were able to get, and if you want as well, you can organize your ideas directly and tell me how this works, right? What parts of the face are analyzed and how that works as well, and the problems that this method may have. Let's do it, please.
Okay, so he's talking about the traditional method, that this is the first one, and this is about facial recognition. He mentioned, I don't know if I catch really well the first word, but I think was fixed balance, that is like creating when you are putting when you want to create this face recognition. This was something like a pixel or something like that. And what the system recognizes is the space between your eyes, your nose, your mouth. So this kind of, yeah, this aspect is what they recognize. They are going to put a numeric code. So this is going to be your face print. So there is not going to be generally two same face prints. Also, he mentioned that you cannot have any expression because this can be like a problem when you are going to put this to this system or technology. The system cannot recognize you. This is what I catch.
Okay, thank you very much, Melanie. Now I'm going to ask you some specific questions to try to organize some details and to see some other ones. The first one, I think you mentioned this, but we have to be sure about this one. What is a face print? They mentioned face print. What is that one, Melanie? How can you explain a face print?
It's like a picture of your face or something like that. You know, like when you take a photo. I think it's something like that. For me, that is face print.
All right, we're going to see that one. And what is the numerical code and how you obtain that code?
The numeric code you mentioned also.
What is that code? They mentioned a code, right? A numerical code. What is that code and how do you obtain that code?
I think you obtain for the number. They mentioned something about fixes in your face or something like that. So I believe that they give you like a number of the space between the aspects of your eyes, nose, and mouth, and they give you a specific number that is going to be the number that they are going to search in the database for your face print.
Okay, and this is the last one because we're going to listen to that once again together to see those details. The last one, do you need to look at the camera for this technology to work, or you don't need to look at the camera? Can you change your expression? Yeah. Okay, so what is the answer? Are you there, Melanie? I cannot hear you. I see that your microphone is on, but I don't hear anything. No, it's off. Try to do it again. I don't know what happened. Something happened, Melanie. I see that your microphone is getting on and off, but when it's on, I don't hear anything, and it's the same when it's off.
Can you hear me?
Okay, I can hear you now. Yes.
Sorry, did you hear my last answer? No.
No, I didn't hear anything.
Okay. So I was saying that yeah, it's necessary to watch the camera and you cannot do any expression. Otherwise, you're going to have some problems in the recognition, and the system is not going to allow you to, I don't know, to do whatever you want to do. So it's going to be like your permission denied.
Okay, perfect. Thank you very much. Now, we're going to listen once again to finish this conversation and to see some details. Many things that you said are very accurate and they are very good, but we have some important elements that we need to try to organize in a different way, and some words that are not actually what you thought they were. So, for example,
Each face has about 80 of these, and these can be translated.
okay, we're going to start right where the traditional method of facial recognition.
Facial recognition. Every face has peaks and valleys.
So every face, and this is a different word, has peaks and valleys. Okay, peaks, one word, and valleys, another word. A valley, for example, in Bolivia, Cochabamba can be a valley. And a peak is like the top of a mountain, for example, right? So every face has peaks, like your nose, and valleys as your eyes sometimes. Okay, so the highest points of your face and the lowest or the lower points on your face. Okay, that's the peaks and valleys. All those shapes and different forms that you have on your face. All right, that's the first one. Then we're going to try to explain again with this information.
And these can be translated into what is termed as nodal points.
Okay, and those peaks and valleys, okay, are going to be translated and are going to be called nodal, okay, nodal points. And a nodal point is just a part of your face that could be a peak, could be a valley, and that is different from person to person. All right, that is a nodal point. And you have a lot of nodal points. Sorry, I'm going to play that one. You're going to listen to the number.
Each face has about 80 of these, and
each face has about 80 nodal points. Okay, a lot of points, nodal points that are peaks and valleys that make, okay, our faces different.
include distance between the eyes, the length of the jaw, the width of the nose, things like that.
Okay, and here in general, we're talking about some measurements. Could be distance between parts of your face, the width, all right, the width, anything that goes related to how you can measure your face. And then this one.
These measurements can be used to create a numerical code.
Okay, and that distance, that measurement, that's going to create the numerical code. Okay, that creates the numerical code that is different for every person.
And this is called a face print.
Okay, and that's the face print. The face print is the numerical code that you have that you obtain from the characteristics of your face that are the peaks of and the valleys that you have.
This system is good because it can compare two-dimensional images such as photographs. The problem
Okay, it's good when comparing two-dimensional things as photographs. But the problems, I think you got this very well.
The problem is that images have to be controlled.
Right, the images have to be controlled. The first problem.
The person has to be staring straight at the camera.
Right, the person has to be staring straight at the camera, as you were saying, right? Staring straight at the camera. And
there must be no variance in facial expression or lighting because
right, and no variance, no changes on the facial expression, right? No smiling and lighting. All right, lighting, that's very important.
As any variance in these parameters reduces the effectiveness of the system.
Right, and any changes are going to reduce the effectiveness of that system. So with that extra explanation and with those little details over there, try to give me one last explanation to finish with this conversation, please, Melanie. What can you tell me about this first traditional method of facial recognition?
So they have
well, I think this is really interesting. At the beginning, they were mentioned in the TV shows. This like a really nice touch when we are talking about science or technology or maybe some labs in the movies. So it's really amazing. However, nowadays there are not too much of this technology because it's really hard to do. You need maybe a lot of income to try to imitate this. There are some companies that are doing something like that. For example, I think Samsung is one of them, that they are putting in the cell phone for your face, and you have the face recognition. However, it's not really and accurate. Sorry. So I think we need to improve, but it's a really good way to. It's a really good like topic that everybody needs to improve because it can be our future.
Okay, perfect. Thank you very much. And now again, to finish with all that thought again and the comment, try to summarize again how this technology works using the words that this person said and that I was restating for you, right? Try to tell me, for example, the first part, what are the parts of our face that are analyzed? What are peaks and valleys? What are nodal points? How do you get these numerical codes? What is a face print? Okay. And finally, again, you can mention a little bit of those problems as a list. Try to do that once again, and let's finish with that, please.
Okay, so we are talking about facial recognition, and they mentioned that they work with these peaks and valleys. That means that the I don't know, the superior or the top part of your face, as you would say in the nose, maybe it's one of the peaks, and also the valleys, like your eyes, and also they mention about this not number, I think what that with this you have this numeric code that is going to be like your face print to help you to system recognize you. And at the end, they mentioned that you don't need to do any expression, otherwise it's going to be a problem with the system.
Okay, and what about the lighting? What about the lighting and, well, right, looking at the camera and lighting, is the lighting going to affect also that facial recognition?
The lighting?
Exactly. For example, if it was daylight or if it's at night, is that going to affect that recognition?
I didn't hear nothing about the light. I just heard about the way you're stand up from the camera and also your expression. I don't think that the light is going to affect.
Okay. And again, just to be sure on that one, we're going to listen to this last part.
And these
So they
parameters
usually
reduces
to
the
go-
expression or lighting.
Okay. Okay. No, I just wanted to show you that they say, all right, expressions and lighting. Okay. So lighting affects, all right. It affects
Okay.
the thing. Okay. So that's it, Melanie. Again, thanks for being here, and I'll see you tomorrow in class. All right. Have
Thanks,
a good
Liz.
night.
Talk to you tomorrow. Bye.
Bye bye. See you.